about superpowers for engineers. So this talk can be kind of broken into two parts. Judd and myself work on different areas, and I'm going to focus more on the philosophy. So don't expect a bunch of data, don't expect a bunch of graphs, just expect a lot of AI-generated images and pictures of my family. It's not a joke, you're going to see some pictures of my family. So one thing we do at Meta is every time we do a presentation, we show our bio slides. So here's my fun bio slide. So for the first kind of decade of my career, I bounced across a few different startups before landing at Meta, or what was then Facebook is now Meta. And so the first half, I was mostly a firmware engineer, doing a lot of firmware design and then failing to deliver the product at the end of the day for lots of reasons, which we'll go into later. But then we landed at Meta, and we started shipping products, shipping hardware, shipping smart glasses. So that's where I work. I work in the wearable smart glasses division as something called a product engineer. And we'll talk more about that. But yes, is a laser pointer on here? So a little bit about me. I love mountain biking. I love skiing. And I love my family and my cute daughter with curly hair. So building a new product segment, it's really tough and really kind of ugly. Having to 0-1 something, and really what we're looking at is not building products, but more so taking on challenges. And that's really what we're doing when we build new products, right? We're signing up to pour ourselves onto a big pile of challenges and see what happens. So essentially, like, how do you 0-1 a product? Well, pretty frankly, you pour developer tears onto a fire, and you wait for a long time, and then eventually you make a product, right? It comes out at the end, and it's like, how did this happen? Well, people cried, people quit, people got really upset. That's if you're lucky. If you're unlucky, then your product just goes away and you'll fail. Just to reference, most of these images are brought to you by Meta AI. I am a company man. So, and then let's say you get the product out the door and you hit some margin of success and you hit product market fit. Well, at that level, you're like, okay, we've had a spark. Now let's pour hydrazine all over this spark and let's just ramp the hell out of this product and let's go, 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 go. Right? Because we have a good process in place. The thing we did from 0 to 1, just copy paste that 10 times and we'll fire this out the door, right? Totally well. Like, you can totally make your playbook, you could totally scale, no worries, right? Well, not really the case. We'll talk some more about some of these challenges here. For example, a major challenge is sometimes you get hit with a pandemic, like we did while we were launching the Ray-Ban Stories, where we built this thing from our living rooms and from our bedrooms with our babies in our laps, trying to ship this thing out the door. But that's fine. That's not going to happen again. But travel bans, those happen all the time. Yeah, which, for different reasons, there's different things we could do. We can go to, new countries. The country's at war now, so my Canadian friends can't go to India for reasons, and we can't go to China for reasons. All kinds of horrible things can happen. But that's fine. Those don't happen very often, right? But they may. And so you have to leverage yourself into this new world of remote work. And if you are a founder of a company, you have to really embrace that this is a reality people expect. And you can tell from the images I chose what my perspective is of remote work. Happy, super driven, motivated faces, right? Yeah, me too. So when we're building the Ray-Ban Stories, it became very clear to me, after my daughter was born, I quoted myself in this slide here. How am I supposed to solve this problem in the factory when I have dinner with my newborn the same day? It's like, do I need to quit? That was legit something that happened. I'm like, I can't be on the call with China because I have this baby in my lap. Why did I sign up for manufacturing support? Why am I helping this? There's got to be a better way. There's got to be a way we could solve these issues, because this is a mess. And in this new era parenting, we're like, hey, dads should be a part of their children's lives, right? Isn't that a crazy idea? That's insane. So how do we do both these things? Well, two there's two big topics here that I've been driving on for the last 5 years at Meta to try to make my life easier and make the life of my coworkers easier too. One is using AOI and AI analysis tools like Instrumental. And the other way is a big thing I've been pushing internally, which is local manufacturing fixturing. We'll talk about that later, why I think that's important and why I think that's a wonderful thing to do. Okay, so I said let's start with the products like those provided through Instrumental and help us solve these problems. So essentially, what this does for us is this allows us, like in NPI, it's critical that we're able to learn as much as we can as early as possible. The problems such as like battery dense, got cut off. I think I saw Anna went on LinkedIn talking about how many battery dense is acceptable number of battery dense during the product development. Like, the answer should be, oh, you guys are good. Okay, and other things like like how much glue should we allow on the speaker cones of our smart glasses? And how many connectors are we allowed to smash during design? Like what's a good number for these things? And it turns out the answer is generally no, or 0. We don't want any of these things. But how do you do it? And why is this useful? Well, this generates actionable signal early in the PDP process. You put these sort of fixtures onto your design, not when you start going to ramp, but when you start trying to understand how you build this thing, or your first build, your proto build, right? And when your volume is like 15 units. Get cameras on every aspect of this thing, and you start understanding where your failures are, and you have documentation saying where your issues actually are. So your engineers, like me, can't just say, we'll deal with that later. It's not a big deal, really, I swear. Which usually means I don't know how to solve it yet. And the unsung hero of the PDP process is the end of it. Basically, once you ship the product out, and like, how does this help? How can we use AI to help support this thing? Well, traceability for one. Let's say you're lucky enough and you ship this thing out, and then you all are celebrating and doing high fives, and then you get one back, a unit back, and you're like, oh, it's failed on us. Okay. Why does it fail? It goes into your FA process, or your early field failure analysis process, and like, we can build traceability here. Now we can see, like, is this failure something like, did they drop it, or do we have some weird defects that went into the world that we didn't see, right? And this is like, this is assuming that you have these sort of AOI processes built onto your MP line, which I think you should. The ops people here say, boo, we don't want that on our, it's too expensive. No, we need it. Engineers want this on the visibility to improve product quality overall. And the other thing I want to talk about was our local manufacturing fixturing. This is something that I'm a huge proponent of at Meta, and we're doing more and more. Basically, you take your CM fixtures and you drop them into a lab, local. It's not the assembly fixtures, more or less, but the test fixtures. Why would we want to do that? Well, and if you went into a build and started your dry run, and you ran your units through the line with your firmware, and you have all these failures going through, and you're like, what? Do we need to solve these failures? There's only like 10 of these things, right? We could solve these on the line. And then it turns out that it's actually like a BSP issue with the firmware, and in order to get your UPH just right, you have to refactor the entire firmware thing, and your whole build goes down. And it occurred to me, like, why do we wait? Why do we wait so long to do these things? So why do we wait until like the build starts, or we start dry run, and we give it 2 weeks to run through this thing? Why do we do that? How come we don't just start a month earlier? To give the developers access to these lines, don't let them to go to China. So you can't go to China. You have to stay home. You have to stay home, and you have to work on these fixtures, on these lines, and develop your tests here. Develop your firmware here. Like, I'm a hardware engineer, right? At the company, I'm not a firmware person anymore. So I get a lot of pushback. Like, why are you investing a bunch of money into building this line in your lab when it doesn't help hardware at all? It just helps firmware people. Well, when you go into a build, we all understand you have so many variables, right? you don't know how well the firmware is going to behave. You don't know how well the hardware is going to behave. You don't know how well the fixture is going to behave. You don't know how well the fixture software is going to behave. So it makes sense to me to really invest in reducing the amount of unknowns. Understand that your fixture and your firmware are going to interact. Understand those issues really early. Because those, like, if your BSP needs to respun, then you don't want 2 weeks to do it. You don't want everyone to be upset about you. You want to have extra bandwidth to get that done as early as possible. And what this ends into, early dry run exit, is you start getting this cascading level of impact where you no longer are slipping your weeks or your days during every dry run phase or EVT phase. These things, and then this leads you to shipping a higher quality product faster. And we all know that that is really the name of the game if you want to establish yourself as a market force. You are able to ship products on time. You don't have to delay your thing. You don't have to write that press release that says, thank you for your pre-orders. Thank you for your money. Oh, by the way, 6 months. You're not getting your product for 6 months, right? No one wants that. That's terrible. So, the big thing here, developer fatigue. I know people maybe making assumptions here, but folks in ops, folks in leadership roles, they're like, yeah, we could solve this problem. Just have the engineers work harder. Or what's the big deal? Have more engineers work harder on this problem to get us through the door quickly. That's fine, but that's not a process. And that's not really something for a sustainable workplace. Imagine instead of having a team of engineers who are on a rotating schedule, as supporting build and then going back to doing things they like, because they know build support is painful. Right? Going to China all the time is super painful. No one wants to do it very well. I'm sure a lot of you folks who come from Apple understand this pain. You're like, oh yeah, it sounded really fun. When I took the job, I'd be in China. We could fly business class. It's great. And then after a few iterations, you're like, oh, that's not fun. That sucks. I don't like doing this. Right? And you're not the only ones. Everybody does this. Build support's painful. And just basically imagine building a manufacturing team who's happy, who's able to get things done on time without being screamed at by all top levels to work harder to get everything delivered on time. So essentially, these things I'm trying to look for is data and signal. So when you have your development signal, we're running through the PDP process. It's really critical to know where it is that you're weak and to understand that small issues matter and they cascade over time. Knowing where you're weak is such a big deal, right? We can know where we're strong, we can know what we're good at, but it's the issues, it's your weaknesses that will end up sinking the ship and keep you from landing your product. And I have a nice quote here. I thought my old mentor had this quote, but he stole it from someone else. But in God we trust, all others bring data, and I think that stands true. Right? We're like, what is our confidence going into EVT? How are we feeling happy? We're like, well, the answer could be, yeah, it looks good, or the answer can be a entire list of all your gluing and connector issues that you had going into it, which I think will help build confidence with people who are investing in your company, right? Showing them all the problems you have versus keeping them secret and saying everything's going to be okay. It's because when you hit that first road bump in EVT, that's when they'll say, I'm not going to give you money anymore. Keep going. So, and the post-launch signal, EFA traceability, I touched on that a little bit. And, it's huge for small companies and big companies, which we'll talk about here. So who is this information for? Who am I talking to? Am I talking to big companies? I come from Meta. We're a huge company, lots of money being poured into our projects. But my background is in small companies, right? Lots of small companies. And so a big sad thing that I found in small companies is that you really make your money or lose your money in EVT. After you build your 15 prototypes, in your proto phase, right? You may not even call it your PDP process. You're just in survival mode. But eventually, you'll build their 15 prototypes, and you'll say, "Cool, now let's start building this product for real." And all those issues we had, we'll deal with them later. And then they show up, and the only way to get through them is to pour money on the problem. And your investors don't like that so much. They don't see you being proactive. They see you just lighting cash on fire with fingers crossed, hoping that there won't be another fire under the next stone. So my message to small companies here is to embrace data, embrace your AOI systems early as possible, to create your list, to create your relationship around risk. Have that be part of what you are, part of your DNA from the very beginning. Now, for large companies, taking these sort of lessons, and it's like, okay, we're going to launch products. We have enough money to pour on the fire through EVT. Good, we're going to launch this thing. But how do we succeed? How do we get from here to there? I like to look at the product generations as part of the PDP process, right? Your first gen is your proof of concept. You're trying to figure out what the market looks like, if you can build things, how can you build things. Once you get that sorted out, you start going to your next phase. Gen 2 product is a little bit more refined. The Ray-Ban Meta glasses are a lot better than the Ray-Ban Stories glasses because we've learned a lot and we carry those learnings over. Essentially, what we're trying to say is like treat your products as stepping stones. You don't want to build the Saturn V rocket from scratch. You got to start somewhere small. You got to start with the right flyer. You got to understand how wings work, like how airfoils work, how lightweight materials work, how these things interact with each other. And from there, you can go into your P-51 Mustang program, where you could build a 0-to-1 airplane in 100 days. If you guys don't know the story, definitely recommend looking it up. It's pretty fantastic. And then once you have that process in place, only then can you go and shoot for the moon. And this applies, to big companies and small companies. You have to have this roadmap in play, and you got to take on problems that are solvable, and then carry over everything you learned, your good process, your good the quality ideas, and bring everything into the next product. And that's how you start to scale. So the big thing, the quality and reliability must flow between products. You have to carry these things through. Essentially, that's all I'm saying. Like, don't just build one thing and then have half your team fire, or have half your team quit because it's so hard to build and everyone was so upset. Build these things in place early, carry this through, and start shipping good products. So, to wrap up my portion, knowing more saves more, saves more time, saves more money. Like, you gotta look what's ahead of you guys, you gotta bring it with you. And when you look back on yourself, looking back at the products you shipped or the phases you've gone through, you have to understand what you did wrong. And if you do all these things very well, then you will be able to have dinner with your family like you always wanted to have, and then you could you could have happy engineers through the whole lifespan. And with that, I'll bring up Judd to talk about some more interesting things.
Hello, everybody. All right, I'll do my own intro, like Miles said. So my name is Judd Nutting. I'm a product design engineering manager at Meta, and what that means is I manage a team of mechanical engineers who focus on product design. A little about me, I'm based outside of Boulder, Colorado, and Miles and I apparently have the same hobbies, also mountain biking and skiing and hanging out with the family. You'll catch us out doing all the Colorado outdoor activities that Colorado has to offer. My career also has spanned many different types of companies, big and small, but has always had product design and development at its core. So I've worked on giant custom industrial equipment for nuclear waste remediation, to handheld surgical tools, to simple plastic mobile accessories that some of you probably have on your phone right now. And now I'm working on the first consumer grade neural interfaces at Meta. So today I'd like to share a little bit how my team and I are using technology to multiply our effectiveness and to build better. Also, I didn't realize that Anna was going to steal my entire presentation, so just forget everything that she showed you and listen to this one. Everywhere I've worked has had some version of this development framework. We've talked a lot about this today, but the basic concept of design, build, test, iterate, do it again, narrow the scope of the changes as you get down the path. There's slightly different ways of naming these things. There's maybe different requirements for different builds, but in general, this has been proven to be a pretty good framework. But usually these milestones progress from low complexity at the beginning. You're building 10 units in the lab, hand putting them all together, maybe your garage or something. In the middle, you have a few fixtures. But at the end, you're like, okay, this is where we can have really cool technology. We can have a fully automated production line maybe. We expect more and more of this technology at the end. But what if we could bring more technology earlier? We've talked about a lot today. All right, so standard data to me is the common stuff that you get in your production line, right? So test fixture output, maybe measurement station output, a go, no go gauge, things like this on the line. You're gonna end up with numbers in a spreadsheet. Perhaps you can review it in real time, but a lot of times, depending on the complexity of your manufacturer, it's not available until the end of the day or later that week or something. So all of these have improved manufacturing quality and helped our engineers understand what's going on. But how can we continue? Again, what can we do to bring technology earlier in the process? So we all know that a picture's worth 1,000 words. We've talked a lot about images today. So what if we took pictures of everything, right? Now you could imagine you'd have all these images, this mess of data might not be very useful if it's not well organized. Or it could be so much data it'd be impossible to derive useful output quickly. I think you'd be right. So again, how do we use these images? We're apparently in this era of big data. I think we're in like bigger data. Apparently the big data was coined in the 90s, so it's a lot different today. We can generate so much data. How do we make it useful? How do you bring value to the production line with this type of new visual data much earlier than a typical maybe end of line single image AOI check? Can we bring these tools earlier? What if there's a way to capture, organize, interpret, and showcase the visual data alongside numerical data? Well, with Instrumental there is. This is not an ad. So I like to call data the ultimate, really the instrumental system or anything like it, the ultimate time machine. The data allows us access to this time machine. So I can now find images of any individual unit at any assembly state at any time I want. This allows me to look back in time and see potential causes of issues that have popped up later. I've also heard this described as a digital thread, so a way to easily walk back path you've taken. This has been extremely powerful in so many ways. So I'm going to dive into some examples of an actual client of Instrumental using their products. So earlier this year, I was in China with my team, as we've also talked a lot about today, during a build, and for the first few days going out on the production line, was trying to solve some problems. I kept thinking, oh man, I wish I had my laptop, because I would totally pull up the Instrumental image for this unit, because obviously something happened earlier, the day before or earlier that day. And so from then on, I didn't have it with me, so I brought my laptop to the line after lunch that day, and then I became like the go-to person that people were asking all day. Can you look this up? Can you check this out? What's going on here? What's the image look like on this unit? So I brought my laptop every day after that. I was able to help find multiple issues that presented themselves further down the production line by looking at the images of the failed units earlier and seeing possible problems. So then I could easily isolate where the problems were occurring on the line, because I had the sequential images as the product progressed through the production line. So then we could work with the defects team or some of the factory team to fix a fixture or improve a process that was causing a problem. Another big example I used was using this to isolate future walking wounded devices that might be compromised. So I had root caused a failure to a NIC and a flex PCB from a bad assembly step. And using the Instrumental app, I was able to highlight that section this is not the actual thing, but this is a demo B-roll here. But I was able to highlight that spot in the image with the failure, query the system, get every other unit that had a similar looking failure, and then get the serial numbers of all those units, and then go talk to the rel team and say, hey, but by the way, these units that you got that were packaged up 3 days ago, they're going to maybe have problems. And so in this way, we could preempt this issue of knowing maybe they could switch allocations with different teams or something for those units, but we would know ahead of time these could be possibly problematic. So as you can imagine, this is an extremely powerful tool for failure analysis. But what if there was more? All right. So as a hardware, mechanical engineer, the fact that I can use AI in a presentation is great. It means I know it's hip and relevant these days. But seriously, we can use these AI tools to help find the problems for us. So what if we could throw all of our test data as well as images in the product throughout the build into a giant bucket, and the system will spit out areas of interest. So that's what we're doing with Instrumental. Like I said, Anna stole my presentation. So the instrumental system will show us areas of concern, and then we can manually go in and see, like, is this actually a problem or not? So it'll highlight discrepancies or drift in what it sees, maybe a screw's missing or adhesive's overflowing. You can go in and check it out. So I've had this tool highlight a specific issue of like a piece of foam that was very important that it was placed very accurately. And it was ever so slightly out of place. The visual inspector didn't get it, but the instrumental system picked it up, saw the drift, flagged it, and now we can go in and improve the process to make sure that this assembly step was fixed. So what about measurements? What if you could create measurements based on visuals in the image and have the system now measure every single unit in the same exact way? You can do that. So I've had this ability to take these measurements and import that into like a database so you have for the rest of the build. And now you can use this to track how those gaps are changing over time. Perhaps it's an important visual gap between two critical parts. You want to see how they change, kind of like it's showing here. All right, so let's say you have, excuse me, concern about something specific. Maybe a higher than expected failure rate on a test, or like a mean shifted test result, or some other known problem that you're kind of expecting something going wrong. You can correlate all those results to the metrics inside the system. For instance, you could provide data, the system could provide data back to you that shows like abnormal position of a grounding foam does impact the RF test result. Very similar, I mean, it was the same type of example that Anna was showing earlier. So I use this correlation tool precisely on the visual gap issue I talked about. When we were able to see how the gap changed based on any other measurement that we could take in the system in the entire data set. So this is so useful for failure analysis and finding a possible root cause for the issue. Also, Anna, you said some customers are getting this next week. Do you like donuts or bagels? Where is she? No. Lastly, I've been able to use Instrumental as my own custom trained quick inspection station. So I can easily train the system to determine what's good and not good and have it automatically flag the operator as they take a picture if it sees something that's out of bounds. So I found this especially useful to help monitor a known issue or ensure compliance with newly implemented fixes. So you might have an operator that's really good and you change something in the process to fix a problem, and then the shift changes and it's someone else. May not have been as well trained. So this acts as that extra backup to understand what is good and not good. So as a manager, a big responsibility of mine is ensuring that the right people are working on the right problems. Often we don't have enough people to work on all the problems or features that are thrown at us. And I've encouraged my team to build efficiency through Instrumental with good results. Many of the engineers on my team see the value and multiply their efforts with the system, enabling them to find root causes of failures much faster on the production line and better understand risks. When you are in China for weeks on end, solving problems quickly is invaluable. So as our products gain complexity, we must also adapt and incorporate technology early in our development process in order to increase our effectiveness and time to market. I know this is what Meta AI gave me for force multiplier. We are always being asked to do more with less. And on the hardware engineering side, there's typically not the scale that can exist in software where a single improvement may impact 1 million users or nowadays even 1 billion users. So products need to be optimized for their very specific design requirements, and that takes time and resources to do well. The cost of travel to manufacturing sites can be high, both dollars and time for your team. So we use Instrumental as our always-on visual inspector, constantly monitoring our parts on the line and allowing the team to focus on the highest value problems. So this technology is becoming the force multiplier for my hardware team and allowing us to find and intercept problems much earlier than before, utilizing these new modalities of information and combining all of that into this flexible system that you can tune to your needs. At Meta, these are the tools we're using to build the future and build better. Thank you very much.
Thank you.